questions 21 through 25 on the 2007 grade 10 Cayley Math Contest. In a soccer league with 6 teams, PQRSTW, each team must eventually play each other team exactly once. So far, P has played 1 match, Q has played 2, R has played 3, S has played 4, and T has played 5 matches. How many matches has W played so far? Let's first write out all the possible games. P plays each team exactly once. So PQ, PR, PS, PT, and PW. These are the matches that P plays. And then very similarly for Q, that team plays every other team only once. Now Q against P has already been counted there, so I don't need to write that in. But I need to write the other teams. QR, QS, QT, and QW. And in a very similar way for R, I have to write those teams, those matches I should say. So R against P and Q have already been written, so I have to write RS, RT, and RW. And the next one is S, ST, and SW, and the final one that I haven't written so far is T against W. Okay, these are the matches. There's 15 of them. All right. So that is the first part of this question. Now we turn our attention to some information they give me. That is that Q has played 2 matches. P had played 1. PQRSTW. So R, they're saying, has played 3. S had played 4. And T has played 5. W, we don't know. W is what we're trying to figure out. Okay. So let's talk about this. Let's first look at T. T has played 5 games. Now, in this big list, T has 5 games, right? So that means T has played all of its 5 games. So T against W, against S, against R, against Q, and against P. All of T's games have been played. So I'll circle the games that have been played. So that takes care of T. Now let's turn our attention to P. P only played 1 game, right? But look, I've already circled that 1 game. It's the one that P played with T. So we've taken care of P. Very quickly, we've done 2 teams. Now let's look at S. S has played 4 games, correct? So I have to circle which 4 games. Now there's 5 games that S plays in this whole tournament, in this whole soccer league. So which ones of those 5 must I circle? I've got to only circle 4. Well, here's the clue. P is already done. P only played 1 game. So the game PS I cannot circle. See what I mean? So that tells me that S against P, this one I cannot circle, because that would mean that P would have to have played 2 games and P only played 1 game. So I can circle all the other ones. So S against T, which is already circled, S against R, S against Q, and there should be one more, S against W. There you go. So done with S. Now let's look at Q. Q only played 2 games, right? Well, we've already circled those 2. In the process of circling the other teams, we circled the 2 games that Q plays. So Q's done. So we're only left with R. R, as you can see, has played 3 games. Well, 2 of them are already circled. This one and this one. So we have to decide what is the 3rd game that R played. Well, it can't be against P. It can't be this guy. Why? Because P only plays 1 game. And it can't be this guy because Q only plays 2 games. So it must be this one. And there you go. Now we've circled all the games that have been played. And based on that, we can figure out how many games W played. Well, let's see. Where's the W? Here's 1 W, here's 2 W's, and here's 3. So of the games that have been played, W appears 3 times, So W played 3 games. So number 21, the answer is C. 5 positive integers are listed in increasing order. The difference between any 2 consecutive numbers in the list is 3. The 5th number is a multiple of the first number. How many different such lists of 5 integers are there? So we have A, B, C, D, and E, and they're in increasing order, so they're like that. And they tell you a very important clue that the difference between any 2 consecutive numbers is 3. So that means that this B is really just A plus 3. And this C is A plus 6. This is A plus 9. And this is A plus 12, right? Exactly based on that sentence. The difference between any 2 consecutive numbers in the list is 3. And that's the only way that will be possible. Then the next sentence, they say that the 5th number is a multiple of the first number. All right, so the 5th number, E, is a multiple of A. But E is equal to A plus 12. So A plus 12 is equal to K times A. And this is what we have to work with. We have to find integer solutions to that equation. So let's see what we get. Make a little table, A and K, and they're integers, so let's start with A equal to 1. And let's see what we get. If A equals 1, this becomes 13 is equal to K. Well, there you go. I just got myself a integer solution for K and A. That's the first one. Let's try A equals 2. If A equals 2, this equation, I'm always going to be working with that equation, is going to be 14 is equal to 2K, and therefore K is equal to 7. So that works. Let's try A equals 3. That equation now becomes 15 is equal to 3K, and therefore K is equal to 5. So there we go. We got another one. Let's try A equals 4. If A equals 4, this becomes 16 is equal to 4K, and therefore K is equal to 4. Okay, let's try 5 for A. If A is 5, it becomes 17 is equal to 5K. K is equal to 17 over 5, which is not an integer. So that one doesn't work. Let's try A equal to 6. If A is 6, we get 18 is equal to 6K. Therefore, K is equal to 3. Okay, we got another one. Now, we keep going here, and to save you the pain of listening to me every single time, I'll just bring it down to K equals 2. Now, K obviously is an integer, so even if you went through every value of A, like 7, 8, 9, 10, eventually you're going to have to figure out K equals 2. That's a quicker way, I think. So that means A plus 12 is equal to, this time K is 2, so 2A. Okay, so that means 12 is equal to A. So there you go. And then the smallest K could ever be is 1, right? Because K represents the multiple that you multiply A by. Let's see what happens when K is 1. Because A plus 12 is equal to A, that means 12 is equal to 0. Well, obviously that's not true. So that's it. These are the only ones. So we got 1, 2, 3, 4, 5, and 6 solutions. And each of those would give you a list of integers. So the answer to this question, number 22, is 6. And that would be choice D. In the diagram, ABCD is a rectangle with AB equal to 12 and BC equal to 18. Rectangle AEFG is formed by rotating ABCD about A through an angle of 30 degrees. The total area of the shaded regions is closest to. First and foremost, I will let this shaded area here be A, and then this shaded area on the bottom be B, and this unshaded area be C. So first look at A plus C. A plus C is essentially just the rectangle, correct? So that, in terms of an area, since the dimensions are 18 and 12, is 18 times 12. And then if you add to that C plus B, that also represents the area of the rectangle, so 18 times 12 again. And that is going to be 216 plus 216, which is 432. Now, we are not interested in C, we only want A plus B. So therefore, A plus B, if you were to add all these guys together, plus 2C, we just figured out was 432. So the area of the shaded region is just A plus B, which is 432 minus 2C. So if I can calculate the area of C, I can come back and plug it into this equation, and that will give me A plus B, which is the area of the shaded region, and I'll be done with the question. So that's what we will concentrate on, trying to find the value of C. So here is my diagram, and what I'm going to do is extend this line AD like that and extend EH like this. And I can call that point P, where they intersect right there, this point right there. Okay, so in this triangle, this is a right angle since it is just that original rectangle shifted a little bit. So if I can figure out the area of two triangles, I'll be done with the question. The first triangle, of course, is the big one, and the second triangle is the small one. All right, so here we go. Remember, this is C. So C is going to be 1/2 base times height. And the base is basically EP, and the height is from here to here, which is AE. But AE is the same as AB, and that was equal to 12. So AE is also 12. So there we go. And then we have to subtract from that this tiny triangle. So that is minus 1/2 base, which I can refer to as this guy, DP, and times the height, which is right here, DH. Now we need to label some angles. They told us in the question that this is 30 degrees. So that means this is 60 degrees. We know this is 90. And therefore this angle in here will be 30 degrees. I'll just write that over there, 30 degrees. Okay, so this is once again a 30, 60, 90 triangle, and we know that the ratio of the sides are 1, 2, and root 3. So to figure out the value, the numerical value of EP, I can use the ratio. EP over AE is root 3 over 1. So EP over AE, which is 12, is root 3 over 1. So therefore, EP is equal to root 3 times 12. So I'll put that in there. We've got 12 root 3 times 12. And this, of course, stays the same. Now we're going to look at this small triangle right here. That small triangle, this is 90 degrees, correct? And this, therefore, is 60 degrees. So again, we've got a 30, 60, 90 triangle with the ratios of 1, 2, and root 3, like that, for this triangle right here, DPH. So therefore, if we use the same ratios, DP over DH is equal to root 3 over 1, like that. So we can isolate for either variable. DH can be root 3 DP over root 3. And in a very similar way, we can get a relationship between DP and HP with that same triangle. It's root 3 over 2. So that means that HP is 2 dp over root 3. All right, so at this point, there's one additional line I want to draw in this question, and that is a line from A to H. If I do that, I can come up with a very helpful Pythagorean relationship, that is AE squared plus EH squared is equal to this AH that I just drew. But AH is also equal to, if you look at the other triangle, AD squared plus DH squared, right? So that's going to help us solve for the value of dp, this one right here. So let's plug all this in. AE is 12, EH is going to be the full from here to here, EP, which we just figured out was 12 root 3, minus HP, correct? And HP we just figured out right here, minus 2 dp over root 3, all squared, and that is equal to AD, which we know is 18 squared, AD squared, plus DH squared, and I can use this. So that gives me dp over root 3, all squared. And this will help us solve for dp. So instead of writing dp every time, I'm just going to call it x, and I think that will help us out. So here we go. We got some algebra to do here. 144 plus 12 root 3 minus 2x over root 3 all squared is equal to 324 plus x over root 3 all squared. Okay, bring everything to one side, put all the numbers on one side, you get 180 over here, and if you bring all the x's over, you get 12 root 3 minus 2x over root 3 all squared minus x over root 3 all squared. Expanding, you get the following. I just actually factored it rather than expanding it. It's easier to do it because this is sort of like a squared minus b squared, and that is a minus b, a plus b, like that. So this is what I get, and this allows me to very quickly solve. This just becomes 12 root 3 minus x over root 3, and this becomes 12 root 3 minus 3x over root 3, and that is equal to 180. And this becomes 432 minus 36x minus 12x plus x squared. And that's equal to 180. Put everything on one side and simplify, and you get this expression is equal to 0. And this factors, this gives me x, 42, and 6, negative, negative. So x is either 6 or 42. Now going back to the diagram, x obviously can't be 42, because what does x represent? It represented dp. So it's just that small distance. So x equal to 6 is what makes the most sense. So we are almost done. We just have to put in our values for dp right here, which is 6. And dh, which is the other one, we can figure out from this equation right here. dh is going to be basically dp over root 3, which is 6 over root 3. Like that. So solving here, we've got basically, the good news is that we can figure out an actual decimal. We don't have to worry about roots and all that. So the first part here is going to be approximately 124.7, and the second part is approximately 10.39, and if you do that, you get 114.317. And remember, our shaded area was a plus b, and it's 432 minus 2c, so it would be 432 minus 2 times what I just figured out for c, which is 114.37, and if you do the math, you get 203.36. And 203.36 is closest to choice C for number 23. The number 8 is the sum and the product of the numbers in the collection of 4 positive integers 1, 1, 2, 4, since 1 plus 1 plus 2 plus 4 is equal to 8, and 1 times 1 times 2 times 4 is equal to 8. The number 2007 can be made up from a collection of n positive integers that multiply to 2007 and add to 2007. What is the smallest value of n with n greater than 1? The first step in this question is to first take a closer look at the number 2007. If you break that up into its prime factors, it's 3 times 3 times 223. So immediately, that makes me think that the set is going to be, for example, 3, 3, and 2, 2, 3. Now, if that is the set, if I multiply those numbers, of course, I get 3 times 3 times 2, 2, 3, which is indeed equal to 2007. But what if I add the numbers in those set? I get 3 plus 3 plus 223, and that is equal to 229, which falls way short of 2007. This sum has to be 2007 also, right? Because the product of the numbers and the sum of the numbers in the set have to equal 2007. Well, you think about this for a little bit, and you come to the conclusion that if I were to put in a lot of ones, I would be able to get the required sum. Now, how many of those ones? Well, take 2007 and subtract from it the sum I got earlier, and that is how many ones. So 2007 minus 229 is equal to 1778. So that is how many ones I would have to put. So let's see what happens if I have this as my set. The product will be 3 times 223 times 1, all of those numbers that are represented by ones. But those ones will not change the product. This product will still be 2007. But by adding those ones, the sum will change. The sum is now 3 plus 223 plus all these ones. And those ones, since there are 1,778 of them, this contributes 1,778. So this becomes 2007. So now we have to figure out how many numbers are in this set. Okay? Well, we have 1,778 ones, plus we have this number, and this number. That's 3 numbers. So the total number in terms of how many elements of the set, it's 1778 plus 3, which is 1781. Okay? So that is one of the answer choices. But the question is asking us for the smallest value of n. 1781 is indeed one value of n for which this works. But, as you can see, we've got quite a few answer choices that are smaller. In fact, all of the answer choices are smaller. Can any of those be possible for n? And the answer is yes. And I will show you how. Going right back to the prime factors of 2007. The prime factors are 3, 3, and 223. So initially I made the set like this, but there's 2 other ways of making the set. You can multiply 3 by 3 and make it 9, like this. And then you can add other elements. Or you can multiply the 3 and 223, and that will give you 3 and 669 as the elements of the set. And just as before, you're going to have a whole bunch of ones here in order to get the sum up to 2007. So let's do each of these and see what we get. So for the first one, The product, of course, is just going to be 9 times 223 times all of those ones, and those ones don't really change the product. This is just going to be 2007. Now the sum, I've got to make that equal to 2007. So it's 9 plus 223 plus a whole bunch of ones, dot, dot, dot. My question is, how many of those ones? Well, if just the ones are left like this, take 2007 and subtract the 223 and the 9, and you get 1775. So in this list, there's 1,775 ones. So the total number of elements in that list are 1,775 ones plus this 9 and this 223. So that brings my total up to 1,777. Let's look at the next scenario. The product, of course, is 3 times 669 times all of those ones, but the ones don't change the product. It's just going to be 2007. Now the sum is going to be 3 plus 669 plus all of these ones, and that has to equal 2007. So now I need to figure out how many of those ones. Again, as before, just isolate all the ones, and on the other side it'll be 2007 minus 3 minus 669, and that gives me 1,335. So that means that there are 1,335 ones in that set. What is the total number of elements in that set? Well, 1,335 ones and a 3 and a 669, so it's 1,337. So I've got 2 additional values for n. I initially got a value of 1781, then I got 1777, and then 1337. And obviously 1337 is the smallest. So that is the answer to number 24, which is choice B. In the diagram, 4 squares of side length 2 are placed in the corners of a square of side length 6. Each of the points W, X, Y, and Z is a vertex of one of the small squares. Square ABCD can be constructed with sides passing through W, X, Y, and Z. The maximum possible distance from A to P is closest to 2. The first thing I'd like to do is join W to X like this. And when I do, I want to illustrate that, of course, this is a right angle since it is a square. And when this square, represented by ABCD, is tilted, it will follow a certain path. And in particular, the path for A is what I want to discuss. How will A move if you are to tilt this square that's in the middle like that? Will it go straight across, or will it go in some sort of a curve? How? The answer is that it will go in a curve, and that curve represents a semicircle like this. That green semicircle I just drew illustrates the path that A takes as you shift that square ABCD. So for example, right now A is right here, but if you shifted the square, A could go here. A could then go here or here, somewhere along the perimeter of that semicircle. Now, one thing that is consistent is that no matter where A is, this angle will always be 90 degrees, because that is a fundamental rule, that if you draw a triangle within a semicircle, the angle will always be 90 degrees. So for example, if I shifted this square and A came right here, then of course the triangle that W, A, and X form will be like this. And that will be 90 degrees. And that's consistent. Why? Because this angle represents the corner of a square. And that corner is always going to have a value of 90 degrees, since the corner of a square is always 90 degrees. So that is a very important part of this question, understanding that. Now they want us to figure out the distance from A to P. In particular, what is the maximum possible distance? So the first thing I want to do is join a line from P to the midpoint of WX. So the midpoint of WX is approximately here. So I'll draw a line from P to that midpoint, like that. Now, WX, the distance from W to X, is 2, right? It's the same as that distance. So that means from the midpoint to X, it will be 1, the distance. Now the distance from X to the edge of that large square is 2, same as that up there, so that's 2. And this distance, well, that's given to us, is 4. So P to the center, which I can call C, we can figure out using Pythagoras. So it will be 4 squared plus 3 squared, and therefore that's going to be equal to 16 plus 9, which is 25, and therefore PC is equal to 5. Now we want the distance from P to A, not just P to C. So what we do is we extend our line that we drew from P to C all the way to A. So there we go. Now notice it doesn't land exactly on that A. It lands on the semicircle, but that just means that A is now here instead of being where it was originally. Now to figure out that distance, it's pretty straightforward at this point, because the distance from C to A is just the radius of that semicircle, which is 1. So A to C is 1, and therefore AP is equal to PC plus AC, which is 5 plus 1, which is 6. All right, but we have to figure out the maximum possible value of AP. We just figured out one possible value, which is a line drawn directly from P all the way through C to A. Now to figure out the maximum, we have to look at the extreme case scenarios and see what happens. The first extreme case scenario is if A was all the way here, all the way at the end, right there. If that was the case, that means the line from P to A would be from here to there. This is, of course, an extreme case scenario where A is basically where W is. All right, let's see what we get. If that is the case through Pythagoras, PA squared is now, this is 1, so that full distance from there to there will be 4. 4 squared, and of course this is still 4 squared. So this looks like 16 plus 16, and therefore PA is the root of 32, and PA is approximately 5.6. All right, so that extreme case scenario actually gives a smaller value than I got previously. Now we have to look at the other extreme case scenario, which is if A is all the way on this side, meaning it's here where the X is. If the A is there, let's see what we get for P. First, let's just draw a line from P to A to illustrate what we're trying to figure out, like that. Now let's figure out the distance in terms of a numerical value for PA. Again, we're using Pythagoras. The distance from there to there is 2. And then this distance, of course, is still 4. So this is 4 plus 16, which is 20. So therefore, PA is root 20. And that is equal to approximately 4.5. So there we go. this is also less than what I had originally calculated. So that means that the value of PA is maximum when A is right here, and that represents a straight line direct from A that passes through C and then goes all the way down to P. So 6 is the maximum value for AP, and therefore number 25, the answer is E.